I'm Duran.
And I'm Roniel. And today we're going to discuss a little bit about WCF and how you can actually interact with them, or as we would say, break them.
Would you do me a
Um,
favor and tell us what WCF stands for and what it is?
it's pretty much a free and open source runtime API for .NET frameworks. If you're actually building an application, a lot of times desktop application, I don't really see them too much in web applications, but more like thick clients or desktop applications, they'll utilize the WCF communications to communicate between either the database or wherever they're trying to actually communicate, which could be an application server as well. So in this particular case, this is interacting with a database, which is
that makes sense.
on the system. So several times in, I guess, dealing with different clients in my consulting career, I've actually came across WCFs, and so a lot of people have been wondering like what they are and how do you interact with them if they're not like something like that is HTTP, and it's kind of crazy because it's not as complicated, but it's complicated. But once you kind of understand how they work and how to interact with them, then you can kind of learn how to break them. In this particular case, it does utilize HTTP, and it's utilizing it on my local host on port 5678. But it also, as you see down here, it actually has net.tcp, which actually sends the data over TCP, but is utilizing it through the .NET Framework API. So more likely, you're not going to see it. You're not going to see that traffic if you're trying to intercept the traffic and use Burp and actually apply your certificate to your local host or your operating system. You're probably not going to see any traffic going through. So you have to find a way to figure out what it is, how to intercept the traffic, and maybe how to get it to go to Burp.
Would you see the traffic if you were using something like TCP dump, Wireshark, etc.?
You should. It is TCP. You should be able to see that through Wireshark, especially like since it's using TCP. You should be able to see that. But the question is, a lot of times, depending on the host, and I experienced this where they're sending, like, for instance, there was an application a long time ago that literally had 10 processors running. They all were talking to an application, and it was doing so much. However, you would have to filter that down and know what you're looking for. But yes, you will see this traffic. That's one of the things you'll see here that is using HTTP, and that is most common, that they don't use SSL. So you'll see that a lot of times that they're using HTTP, which you can, like I said, you can see that through Wireshark. Do something. I have a tool here. You don't really need this tool if you don't want to. I'm just show you different ways that I actually go to figure out what's going on. But if you know already that it's WCF and it's using a lot applications utilizing WCF, you can use WcfScan and kind of see from a basic view or what type of low-hanging fruits that it may have. So whether it has encryption and does it have any security modes enabled. So right now we're going to go through and we're going to grab this host here. And then we're going to see if there are any issues that we can find really quickly with this tool. So the server accepts non-security mode. Not good. Warning, no authentication or transport encryption enable and binding, and it rejects transport mode. So here we already know that it's not using SSL. So this is just a quick way to, if you already know that the application that you're testing is using, this is a quick way to kind of see if you can find any low-hanging fruits.
Would your preference be disassembly to figure that out, or something like that, similar to what we saw in the reconnaissance phase, or would your preference be testing and touching first to figure out a lot of that data, and why?
I normally go to disassembling an application, but in a particular case, just say for a client I was testing for, they were using, the application was utilizing C. So the DLLs were like C#, but the application itself was in C. So most of the time, depending on what it is, if it's C#, and if it's C, I can still go through it and read it, or I can use reverse engineer it using a disassembler. But a lot of times I would try to decompile the application because majority of them are using the .NET, right? But a lot of times they're a mixture. So in this case, they're using C, but they did some functions that were called there, and they were calling it through a .NET WCF API, and they utilized the DLL to do that as well. So I was able to decompile that and see some of the information, but I really didn't get a lot of the. So you may get one of the service endpoints and you may not. So it may not actually call the service endpoint inside of the actual application.
Right.
You may have to go looking more to find more information. Another way I did that was using something called Process Hacker. So, and Process Hacker allows us to do a lot of different things. We can look at the strings and memory. We can inject things. We can do a lot of different things. We can look at privileges that the application has and any security, that the application actually utilizes.
Right.
So in this particular case, we're going to go to the properties section. As you can see here, we have a memories tab here. We're going to go to the memories tab and we're going to click on the strings button. Going to keep it minimum. And then on the filter option here, in the contained, we're going to look for any HTTP strings. And we seem to get a lot of them. So we just need to see if we can find anything in here. Normally, you may find the actual services that it's using, and you may also find the WSDL.
Right.
Which could give you more information about all of the functions that they actually utilize that you can call and use as well. So here we have some HTTP, some services here that we can actually go to. So we could actually put that in the proxy or try to find some way to intercept that and see if we can actually interact with that service. So that's a good way to do. That's not the only way. Like I said, if you're actually using Wireshark and you're sniffing, you should be able to probably get information about that service as well. It's going to be probably localhost, most likely when you're doing an internal assessment on a thick client, you're probably going to be localhost on their host, or it may be whatever their host name is. So you can either do it the Wireshark way, you can do it through memory and find the strings, or you can also see if you're lucky, you can see if you can look at the strings to disassembler and see if they actually have those endpoints, or you can try to reverse engineer it if you can decompile it as well.
Right. And another benefit really to doing both is looking at the code, you can see quite a bit of stuff that you would not know to test, and you can see places you should test. But also looking at it running, you can see things that are maybe specific to this configuration, this installation. It could very well be that the code would otherwise be secure, except the configuration is insecure. It points to a non-HTTPS, for example, endpoint, or non-TLS encrypted endpoint.
Yep. And like I said, that is one vulnerability here that they're not enforcing encryption. So anybody can sniff this traffic if they're on the network. And they also, as we're going to see, they do not utilize, when we start to interact with the application, they do not utilize any authentication.
It's unfortunately common.
They could make sure that and check that user is actually a valid user, but it seems like with thick clients, they don't actually check that the user is authenticated before they actually go. So I can close out of that desktop application and still use the service.
Right.
So when the session expired, they don't actually check whether the session had expired or whether the user is authenticated as well. We have also AppSec Labs WCF Toolkit Manager that you can utilize on any project. But I pretty much like WCF Storm. I think it's a lot better interface. So if you want to utilize that, it is a pretty good tool to use if you want to interact and use something to intercept. But you can also use this tool to send the data straight to Burp and then interact that way. So that's what we're going to do.
Burp code.
Yeah. So in the AppSec Labs toolkit, we have two types of actions, and one action I have the choice of actually entering the endpoint if I already know what the endpoint is. And the other one is I could utilize a proxy if I already have a proxy. So we're going to go with that option. We're going to use external proxy, and we know that localhost 8080. We're going to browse to the application that we actually want to intercept. All right, we're going to turn intercept requests on and intercept response on, and then we're going to at least check that box, and then we're going to turn it on. So we're here in Burp. We centered all the traffic, or sent all the traffic to Burp so we can intercept it. However, it kind of sucks because you kind of have to, you can utilize Burp, but you still have to go back to the third or the man in the middle application, which is the toolkit. So we're going to forward that traffic over. All right. And then we're going to go back to our the man in the middle, right? So it received a request so we can submit it. And we have this pretty application. I lied, but it's okay. So we're going to enter in.
Looks like I wrote it.
Yeah, it looks like you wrote it for play, but yours is actually better.
Well, I know. I'm really talking about that user interface, man.
We're going to accept this after we use, enter in those credentials. And let's look at this response. Now, before we actually send that response over, we can actually modify the response here. So let's look at it. We can modify the time here if we wanted to, would be, I guess it would go to a log that might be in log injection, timestamp injection, or something like that. We also see here that this is pretty stupid, but in a real environment, you might get a client that, or somebody who developed this, that might have, I wouldn't say delete the database, but might have an administrator option here that they didn't know that they had in the response or in the request that you can turn on. A lot of the times it may be a mass assignment where you can actually, you see something in the response, you can actually put it in the request, and then it will actually, you can set that delete or that admin user that you want to become to true instead of false.
Right. Because so often they expect the user interface to do the validation by either having or not having an option. And so they don't verify on the actual server side. We had a company that actually, when I sat there and told them, hey, you guys need to be checking all this stuff server side, you should check client side too, because nobody likes to see errors that are unknown, but you've got to check it on the server side. They actually told me their previous security team had told them to do everything client side. And I was going, what? What did you say?
Yeah, that is crazy. And in this case, we're actually doing a client side bypass. So It's crazy. You want to actually check on the server as well. That is, it's really common to see that people don't actually check and validate things on the server side.
Yeah.
So you have to validate not only on the client side, but you have to validate on the server side as well. So in this case, we're going to leave this true. It should have been false, but we're going to leave this true so it can actually delete the database. Boom, it went over. It's going to delete the database. And what it should do, it should actually send you, it'll pop up a box to say your database was deleted. This is just a basic idea of how to interact with WCF communications or APIs. Later on in an episode, we will go over other techniques or other things you can actually do with this. Some of the things that you can actually do is some injection attacks. You can actually reroute. This is going to a particular route. I can change that and actually send it to another location and route that request to me. And all of the requests will start coming to me instead of the admin or the manager. So we can look at that and some other things that we can do with this particular request. But however, this has been our segment. This is the end of our segment. I am Roniel.
I am Duran.
And if you haven't already, please like, comment, and subscribe for more content like this. If there's anything else you want us to talk about or you want to see, please list it down in the comment section or email us. We would love to talk about anything you guys want to hear or talk about. Until the next time.
Have fun.
Have fun. So, and I am using the WCF Hack Me casino sample or example, which you can get from AppSec Labs if you want to test it out. And we have two applications. We have the client, which is a betting application, and we also have a casino management application. So it allows you to log in as the manager. So it's pretty basic, simple application, but I just wanted to show you guys how you interact with WCF, and then we'll go further on how you can actually do some pretty bad things. So let's look at the manager application.
Burp code, Windows code. God, you just.
All right. Oh, my virus did not like that. Goddamn AVG.
It's on to you. I mean, it's not wrong.